Right now, as you're settling into your cozy corner of Earth, maybe wrapped in blankets, perhaps gazing out at the night sky, you are moving in ways that almost defy imagination. The ground feels so steady beneath you, your room feels unmoving, yet you're traveling through space at 67,000 miles per hour. You are spinning on a rock, orbiting a star, caught inside a galaxy that is itself hurtling toward an unimaginable collision. All of this is happening while the very fabric of reality stretches and expands around you at speeds that would make light itself seem sluggish. It's the kind of thought that can make your chest tighten, like standing too close to the edge of a cliff. But here, in this moment, you're safe, warm, and ready to let your imagination step into a space so vast that words themselves strain under the weight of describing it. Welcome to the sleepless unknown. I'm so glad you're here. Maybe you found this channel late at night while lying in bed, your phone balanced against your pillow, or maybe you're listening from a quiet corner of your room with the lights turned low. Wherever you are, thank you for letting me keep you company. If you're in your pajamas, nestled under a blanket, perfect, because what we're about to explore tonight is the kind of story best heard in comfort. Before we set off, a small thank you. Every like, every subscribe, every gentle tap of support helps keep these journeys alive. I'm deeply grateful. Of course, I should give you a little warning, though this is the sleepy Cosmo, and you may very well drift off while listening. The ideas we're about to wander through have a way of keeping minds awake. They spark little fires of curiosity, the kind that pull your thoughts upward toward the stars, even when your eyelids are heavy. If you do fall asleep, that's okay. The universe will still be here in the morning, patient as ever. So what are we doing tonight? We're not just asking, how big is the universe? That question alone would make for a long conversation. But tonight the stakes are larger. We're embarking on a journey that might quietly, irrevocably shift how you see yourself. Because once you understand even the faint outline of the cosmos's scale, you can't look at your life, your planet, or even your place in existence the same way again. Imagine this, a single grain of sand resting on the tip of your finger. Hold it up to the night sky. Within the space that grain of sand covers, telescopes like the Hubble have discovered thousands upon thousands of galaxies, each containing billions of stars. If one tiny grain of sand hides such immensity, what does that say about the rest of the sky? Already we begin to feel the tug of vertigo, the strange mix of wonder and disorientation that comes when we step outside the narrow scale our senses give us. Our everyday lives operate in a world of meters, miles, and maybe, on rare occasions, transcontinental flights. Distances are things we can drive, walk, or imagine crossing with enough time. But the universe resists those instincts. It isn't simply large, it's so enormous that our minds instinctively shrink it, rounding it down into something we can hold on to. A trip to the moon feels like it must be around the corner. The nearest star, perhaps just a little farther, the galaxy, surely within the realm of a long enough journey. These are the illusions of familiarity, comforting lies we tell ourselves to soften the incomprehensible. Tonight we will gently peel back those illusions and gaze at what lies beneath. But don't worry, we won't sprint through the stars. This isn't a race, it's a bedtime voyage, a quiet unfolding of distance after distance, layer after layer, until the universe reveals its staggering immensity. We'll take metaphors as our lanterns, analogies as stepping stones across the abyss. Sometimes we'll shrink the cosmos into objects we can hold, marbles, basketballs, dinner plates, just to remind ourselves of where we stand. Other times we'll simply let ourselves drift, carried by numbers so large they feel less like quantities and more like poetry. Picture yourself at this moment. You're lying down, perhaps listening with your eyes closed. Your breathing has settled into its familiar rhythm. Above you, though unseen, the ceiling of your room is dwarfed by the greater ceiling of the night sky, and beyond that ceiling lies no end at all, only vastness. You are a passenger on a world that never stops moving, never stops falling into its orbit, never stops tracing the same cosmic dance it has performed for billions of years. The paradox is beautiful, complete stillness in your body, paired with unimaginable motion in your reality. As we begin, let's take a gentle step back. For thousands of years, humans have looked upward and wondered about the sky. Ancient civilizations filled the heavens with stories, hunters and lions, heroes and monsters, gods and myths. The stars were narrative canvases, backdrops to explain what was otherwise inexplicable. For most of history, the universe was thought to be just beyond the dome of stars, small enough to be traversed by gods, intimate enough for mortals to imagine climbing toward. The cosmos was something to see, not something to measure, but measurement arrived, little by little. First came the realization that the earth was round, spinning like a ball on an invisible axis. Then came the understanding that the sun, not our planet, was the center of our system. Each discovery widened the stage, pushed the walls outward, stretched the edges of what universe meant. Eventually, telescopes showed us galaxies beyond our own, and suddenly the universe wasn't simply large, it was unthinkably populated. Each century seemed to whisper to humanity, "It's bigger than you thought." Tonight we continue that whisper, but at a scale so overwhelming it risks slipping into silence. What we'll see is that the question, how big is the universe, is like peeling an onion, layer after layer, each bigger than the last and no clear end in sight. Every time we think we've reached the boundary, a new perspective opens. It's as though the universe delights in challenging us, forever offering the next level of awe. But let's not get ahead of ourselves. Before we can stand on the doorstep of galaxies, we must ground ourselves in the familiar. Your body, this room, this planet beneath your feet, because the cosmic journey is easiest to appreciate when we tether ourselves to something known. Think of it like holding the handrail while gazing from a skyscraper balcony. That handrail, for now, is Earth. As you lie there, remember that Earth itself is a ship in motion. Every second, it carries you around the sun, your orbit so steady you don't feel it. That sun, in turn, is not fixed. It drifts along a spiral arm of the Milky Way, part of a galactic flow so immense that billions of stars share in its motion. And that galaxy, too, is moving, pulled like a leaf in a cosmic river toward a future collision. The sheer stacking of these motions, planet around star, star around galaxy, galaxy toward neighbor, is dizzying, yet it is also strangely soothing. Because if everything is in motion, then perhaps the truest form of stillness is simply to exist within it, letting the current carry us. So take a deep breath. Feel the rise and fall of your chest. Inhale the air that has cycled through countless generations, atoms once part of stars, now part of you. Let yourself settle into the rhythm of existence, for tonight we won't just drift off to sleep with simple dreams. We will drift outward, farther than any spacecraft has traveled, farther than even light from ancient stars can yet reach, guided by imagination, curiosity, and the quiet companionship of this moment. By the time we're done, the question, "How big is the universe?" won't just be about numbers or diagrams. It will be a mirror held up to your own sense of place, an invitation to see your life as part of a story grander than any myth ever written. That is the journey we're beginning right now. So let's dim the lights, pull the blankets close, and take our first step outward. We'll start nearby, with the world we know best, and then, layer by layer, we'll push past the boundaries of sight, of thought, and perhaps even of imagination itself. We begin close to home. Your feet are planted on earth, your breath moving softly in and out, the air still and steady around you. Above you, if the clouds are kind, hangs the moon. It looks gentle, bright, almost reachable. At some moments it feels as though you could stretch out your hand and brush its surface with your fingertips, as if the quiet orb were only a climb away. Yet that glowing face is no neighbor in the ordinary sense. It is 238,900 miles from where you sit right now. To make sense of such a distance, let's bring it down to human scale. Imagine holding a marble at arm's length in front of you. That marble is Earth. The moon in this shrunken model would not be nestled right against it or hovering just a step away. It would be a small pea placed 10 feet from where you stand. A marble and a pea, companions in a tiny dance, separated by a space larger than most rooms in your home. That gulf of 10 feet is the illusion the cosmos offers us. The distances we think we know are not what they seem. We grow used to the sight of the moon, its waxing and waning, its serene presence in the night sky, and we forget the yawning chasm between us and it. In truth, that space is so wide, you could line up every continent on Earth end to end, and still, the gap would not be filled. Now, if Earth were still our marble, let's ask, what about the stars that twinkle beyond the moon? Surely those are near as well, waiting just beyond the darkness. We gaze up, night after night, and feel as though they are placed on some great ceiling, sprinkled across a dome no farther than the sky itself. The constellations appear stitched together, a tapestry we can trace with our fingers. But here the illusion deepens, and with it comes the first touch of vertigo. If Earth were that marble, then our nearest star beyond the Sun, Proxima Centauri, would not be another marble sitting across the room. It would be a basketball placed 1,000 miles away. Pause and hold that thought. A marble before you, a pea 10 feet off to the side, and then nothing. Empty air, empty land, empty sea, nothing for 1,000 miles. Then, finally, a basketball. This is our friendly neighborhood cosmos, revealed not as a bustling street of nearby houses, but as an ocean of staggering emptiness, dotted here and there with solitary islands of matter so remote they might as well be legends. That emptiness is the true stage of the universe. Our eyes deceive us, making it feel crowded with stars, when in fact the stars are scattered so sparsely that the comparison stretches language itself. The sky is not a tapestry, it is a desert with lights glimmering at distances that swallow the imagination whole. Proxima Centauri, that closest star, sits 424 light-years away. Light, the fastest thing we know, a traveler that sprints at 186,000 miles every single second, still takes more than 4 years to make that journey. Imagine turning on a flashlight and waiting 4 long years for that beam to arrive. The glow you see from Proxima Centauri tonight began its journey while the world was locked down, streets quiet, cities hushed by the shadow of the COVID pandemic. You are not seeing the star as it is now, but as it was then. In that way, time and space intertwine. Every glance upward is not just distance, it is memory. Every star is a story told late. Let us pause in that idea. The light that graces your eyes is not current. It is history, traveling across unfathomable gaps to finally brush against your vision. That small flicker above your head may already be gone, extinguished centuries ago, while its light still journeys across the void. The heavens you look upon are a patchwork of pasts, layered and overlapping, a cosmic scrapbook written in photons. The illusion grows stranger still when we compare it to what feels familiar. If you board a plane and fly from one end of the earth to the other, perhaps 20 hours pass. That is a marathon in human terms, long enough to make your muscles ache, your patience wear thin. Yet that journey spans only a fraction of the marble that is our Earth. Crossing from one hemisphere to the other is less than the width of your fingernail compared to the 10-foot leap to the moon. That leap in turn is nothing compared to the 1,000-mile stretch to the nearest star. Imagine a caravan setting out, determined to walk the 1,000 miles from marble Earth to basketball Proxima Centauri. Every step a mile, every mile a lifetime. Generations would pass before the travelers even glimpse the faint curve of their destination. The enormity of it transforms space into something else entirely. It is not merely a place, it is a force that dwarfs us, stretches us, humbles us. This is why our brains whisper gentle lies. They compress, they flatten, they bring stars closer than they are. Otherwise, perhaps we could not bear the truth. To live beneath a sky where every light is an unreachable past, every neighbor a million lifetimes away, is to stand on the edge of a boundless sea without a boat. So we trick ourselves into believing it is manageable, familiar, close. Yet tonight we will resist that trick. We will look squarely at the scale as it is. Think of Earth again, spinning with its pea-sized companion 10 feet away. Think of Proxima, that basketball impossibly far, its light already years old as it greets your eyes. Now imagine the spaces between not as blankness, but as an ocean whose waters are invisible. Vast tides roll there, currents of radiation, whispers of gravity, the faint hum of cosmic background. It is not empty at all, not truly. It is filled with the silence of distance, the echo of creation stretched so thin it feels like nothingness. As you lie there, perhaps your chest rises with a different kind of breath, a breath tinged with awe, with that strange mix of fear and wonder. Because to know this is to feel yourself both shrunken and expanded. You are tiny, yes, a speck on a marble adrift in the infinite. Yet you are also vast because your mind can hold these distances, can shape metaphors, can bend imagination far enough to stretch across the abyss. That capacity is its own kind of spacefaring. Now let us take a step deeper. If Proxima Centauri, our nearest stellar neighbor, requires 4 years of light-speed travel, what of the other stars you see twinkling above you? What of those that form the constellations you know by heart? Orion's belt, the Dipper's handle, the cross that points south. They are not single places, but collections of suns at vastly different distances. The patterns are illusions too, stitched by our perspective, not by reality. Some are dozens of light years away, some hundreds. To your eyes they align neatly, but in truth they are scattered across space like pearls spilled across a floor, each lying at its own unreachable distance. The first vertigo moment is not merely the recognition of emptiness, but the realization that everything we see is skewed. Distances collapse into neat shapes, stars become neighbors when they are strangers. The sky itself becomes a mask. Beneath it lies a truth more complex, more immense, more dizzying than the mind instinctively accepts. This is where time begins to weave into the story, inseparable from distance. For to look far is to look back, to see not the present, but the past delivered by light's patient voyage. Every star becomes a memory. Every glimmer is an echo. The farther we look, the deeper into history we fall. The dance of time and space has only begun. Already the moon, the pea 10 feet from our marble, whispers of the gap between appearance and reality. Already Proxima Centauri, the basketball 1,000 miles away, tells us that the universe's distances cannot be crossed by thoughtless steps. Already the photons in your eyes remind you that the night sky is a map not of what is, but of what was. We stand now at the edge of a greater revelation, ready to step beyond these first illusions of closeness. For if even our nearest star requires such stretches of imagination, what then of the rest of our stellar neighborhood? Leaving behind the comforting familiarity of our solar system, you begin to step outward into the quiet expanse that lies beyond the reach of our sun's influence. The planets we know, Mercury's scorched face, Jupiter's swirling storms, Neptune's icy blue winds, fade into the distance until they become no more than faint whispers in the dark. The solar system, vast as it once seemed, collapses in your mind into a single speck, a glowing ember adrift in a sea. Scattered across the horizon, in no particular order, lie distant cities, each radiating its own light, each separated by stretches of wilderness so deep that traveling from one to another feels almost somehow able to climb aboard a commercial jetliner cruising at a comfortable 550 miles per hour and pointed it toward the very nearest star beyond the sun. Your journey would last for 5 million years. Think about that. The machine designed to carry you across continents in mere hours would not deliver you across the gulf of a single star system in all the time that separates us from the dawn of the human species. Distance here is not simply a matter of space. It bends time into something unrecognizable, a scale so immense that the word impossible feels almost insufficient. Take our nearest stellar neighbor, the Alpha Centauri system. To the naked eye from Earth, it appears as a single bright star in the constellation Centaurus, but in reality it is a family, 3 stars bound together in a slow, graceful orbital dance. The 2 larger ones, Alpha Centauri A and B, orbit close enough to one another that, if you were standing on a planet circling one of them, the other would blaze in your sky with a brilliance unlike anything we know. A smaller companion, Proxima Centauri, lingers farther out, a dim red dwarf holding the title of closest star to us at just over 4 light-years away. Its light, the faint glow now reaching your eyes, left in 2019, when our world was still reeling from the first waves of the pandemic. That means every time you glance at Proxima, you are seeing the past, not metaphorically, but literally. This is the disorienting truth of our stellar neighborhood. Nothing here is truly now. Distance forces delay, and delay rewrites time itself. You can't wave at a star and expect it to wave back. By the time your greeting arrives, civilizations might have risen and fallen on any worlds orbiting its light. Now imagine, once more, our Earth as a marble resting in the palm of your hand. The sun becomes a radiant lamppost illuminating the space around you. The moon sits nearby like a pea, orbiting close enough to feel companionable. But the nearest star, Alpha Centauri, refuses to play along with such intimate scaling. In this model, it becomes a glowing basketball positioned 1,000 miles away. Between your marble Earth and that distant ball lies nothing but empty road, stretching further than your eyes can see, with no pit stops, no signs of life, just endless darkness. This is the reality we inhabit, hidden behind the trickery of twinkling points of light in our night sky. What makes the vastness even more haunting is that Alpha Centauri is only the beginning. When astronomers map out the sphere of space within 100 light-years of Earth, they find roughly 14,600 stars scattered through the void. That may sound like a bustling community, but spread across a bubble of such size, the neighborhood is far more lonely than crowded. Each of those stars could host worlds of its own, orbiting silently, carrying unknown stories, or perhaps no stories at all. Yet their sheer distance ensures that, for us, they remain as untouchable as dreams. Think about how far 100 light-years really is. A single light-year, the distance light travels in 1 year, equals nearly 6 trillion miles. Even if you could somehow ride upon a beam of light itself, streaming outward at 186,000 miles per second, it would take you a century to cross that neighborhood sphere. 100 years of travel at the absolute maximum speed permitted by the universe, just to reach its edge. Every moment of recorded human history, from the earliest scratch symbols of Mesopotamia to the launch of the latest satellites, would not be enough time to complete the crossing. Humanity, in its entirety, could live and die within the span of such a voyage, and still you would not have arrived. The numbers numb the mind, but they also hint at something profound. Within this neighborhood of 14,600 stars lie possibilities beyond counting. Even if only a fraction of them host planets, and even if only a fraction of those planets harbor conditions resembling Earth, the number of potential worlds spirals into the thousands. Picture each one not as cold statistics, but as a stage where stories might unfold. Perhaps a small ocean world covered in shimmering waves, its skies streaked with twin moons. Perhaps a rocky giant, its surface lashed by winds so fierce that mountains grind themselves to dust. Perhaps even a quiet, fertile globe where creatures, unaware of the vastness beyond their skies, carve out lives under alien constellations. As we drift through this suburban sprawl of the galaxy, it becomes clear that what separates us from those imagined worlds is not simply distance, but perspective. Our human minds, trained by survival to measure in footsteps and heartbeats, cannot naturally stretch to contain trillions of miles. So we use metaphors, maps, and numbers, trying to fold the incomprehensible into something the heart can grasp. Yet even these tools stumble. For when you realize that to cross the void to Alpha Centauri at jetliner speed would take longer than the entire span of human existence, you begin to sense the scale at which the cosmos truly operates. But the neighborhood does not end here. Alpha Centauri may be the closest, yet beyond it lies Barnard's star, Wolf 359, Leyland 21185, names that sound like whispered coordinates on a star chart, each pointing to another beacon shining faintly through the void. These stars, some smaller and cooler than our sun, some larger and hotter, all contribute to the tapestry of the local neighborhood. They are not scattered randomly, but bound into the gravitational weave of the galaxy itself, caught in its slow, steady rotation. Like streetlights in an endless city, they stretch outward, hinting at the immensity yet to come. To place yourself within this sprawl is to confront humility. Earth, for all its oceans and continents and civilizations, is but one marble in an immeasurable field of stars. Yet there is also wonder in this realization. Our sun is not lonely, it is one among thousands in this nearby bubble and millions more beyond it. Each point of light in the sky is a neighbor, even if the neighborhood stretches across gulfs too wide for footsteps, too vast for journeys as we know them. The suburban analogy is fitting in more ways than one. Just as houses in a suburb each contain lives, histories, and quiet dramas hidden from their neighbors by walls and distance, so too do the stars contain their secrets, locked away behind distances that, for now, remain uncrossable. But the very act of knowing they exist, of naming them, of mapping their places in the sky, draws us closer in spirit, if not in space. We stand then, at the edge of understanding, gazing into a stellar neighborhood that feels both familiar and impossibly alien. Each star is a lantern hung in the night, marking not just a place in space, but a chapter in a story that is still unfolding. The question is no longer whether we can imagine the scale, but whether we can live with the vertigo it creates, knowing that even within this so-called neighborhood, our world is dwarfed into near nothingness, yet the neighborhood is not the whole. Beyond this suburban sprawl lies the broader structure of the galaxy, a spiraling city of stars so vast it dwarfs even the staggering emptiness we've just crossed. To move from neighborhood to metropolis is to trade the silence of empty streets for the roar of cosmic traffic on a scale almost impossible to envision. The neighborhood we just crossed, with its scattered stars and quiet distances, feels immense when considered on its own. Yet, in truth, it is barely the opening block of a city so large that it nearly defies imagination. Zooming out now, letting the map unfold, you see the boundaries of your familiar streets dissolve into something far greater, the Milky Way galaxy itself, a sprawling metropolis of light containing hundreds of billions of stars. Think of the first photographs taken of Earth from orbit. Before then, our planet was only understood from the ground, experienced through the immediacy of landscapes, seas, and skies. Then suddenly, we saw it from above, a fragile blue marble suspended in blackness, at once impossibly small and achingly beautiful. That change in perspective rewrote how humanity thought of its home. Now apply that same transformation again, not to Earth, not even to the solar system, but to the entire stellar neighborhood. From this higher vantage, the thousands of stars around us collapse into a tiny patch of real estate tucked into the body of a grand spiral galaxy. The Milky Way, our galactic city, is not a simple circle of stars. It is a barred spiral, its luminous arms sweeping outward like the strokes of a cosmic pinwheel. Roughly 100,000 light-years across, it is vast enough that a beam of light, racing at the ultimate speed limit, would need a full 100 millennia to travel from one edge to the other. Within that space reside perhaps 400 billion stars, each with its own planets, moons, asteroids, and mysteries, a population so large that to count them one by one, naming each as you go, would take longer than all of recorded human history. Where, then, do we belong in this stellar metropolis? Not at the shining heart, where the stars cluster densely around the galactic center, nor at the distant rim, where the light thins into obscurity. Instead, our sun finds itself in a modest neighborhood called the Orion Spur. It is not a grand avenue of the galaxy, but a quiet side street tucked between two of the Milky Way's sweeping spiral arms, the Sagittarius arm and the Perseus arm. This location, balanced between bustle and solitude, has shaped the story of life on Earth. Too close to the galactic center, and we might have been drowned in radiation or shaken by frequent stellar collisions. Too far into the outskirts, and heavy elements essential for planets and biology might have been too scarce. By a stroke of cosmic luck, or perhaps the inevitability of probability, we are parked in a residential zone perfectly suited for a young species just beginning to look upward. Picture the spiral arms themselves as glowing rivers of stars, gas, and dust flowing outward from the galactic bar at the center. They are not solid structures, but patterns, regions where stars are born in great waves, glowing like street lamps along the avenues of the city. From within the Orion Spur, we cannot step outside and take in the full view. The galaxy surrounds us from every angle, its structure hidden by our embedded perspective. It is like living within a forest so dense that the shape of the woods is only guessed at by looking at the trunks and leaves around you. Yet, through radio telescopes, infrared surveys, and painstaking mapping, astronomers have pieced together the grand silhouette of the Milky Way, tracing the outlines of the very metropolis in which we live. As your gaze turns inward, toward the center of the galaxy, a strange awareness emerges. Some 26,000 light-years from our Sun lies Sagittarius A, the beating heart of the Milky Way. But this heart is not a star. It is a supermassive black hole weighing in at 4 million times the mass of the Sun. Invisible to ordinary sight, it reveals itself through the dance of the stars caught in its grip, whipping around its unseen mass with speeds and accelerations that defy ordinary comprehension. There is poetry in this irony. At the center of our galaxy, the anchor that binds this metropolis together is not a beacon of light, but an engine of darkness, a destroyer of worlds, a devourer of matter, a place where gravity crushes space and time into something unrecognizable. Yet it may also be the reason the Milky Way exists in the form we see. Without Sagittarius A, the spiral arms might not have formed as they did, the stars might not have clustered into this graceful pattern, and our Sun might never have had a place in which to rise. The black hole, terrifying in its nature, is at the same time a cosmic city planner, sculpting the very home we inhabit. From Earth, the center of the galaxy is hidden behind veils of dust, its true face obscured to the naked eye. Yet when astronomers point their instruments toward Sagittarius, peel back the layers of obscuration, and watch the motions of stars close to the black hole, they see orbits drawn like chalk circles around an invisible point. One star in particular, known as S2, completes its looping path every 16 years, swinging so close to the black hole that its velocity climbs to thousands of miles per second. That single orbit was enough to confirm the presence of Sagittarius A, a dark heavyweight orchestrating the ballet of the galactic core. If the Milky Way is a metropolis, then Sagittarius A is its paradoxical downtown, a region of both creation and destruction, where the density of stars grows so intense that the sky would blaze with thousands of suns if you were standing on a world orbiting there. The radiation, however, would be overwhelming, a ceaseless bombardment of energy. By comparison, our Orion Spur feels like a quiet suburb, tucked far enough from the roar of the center to allow life to settle and grow. Our perspective is limited, but imagination carries us further. picture rising above the galaxy itself, looking down upon its spiral arms as though from some impossible height. The Milky Way unfurls beneath you like a glowing disk, its stars painting rivers of light against the black canvas of intergalactic space. Somewhere within that disk, a small yellow star burns with ordinary brightness, encircled by a few planets, one of which carries seas, forests, deserts, and billions of lives. It is an address so minor that from this vantage it all but disappears, yet it is also the only home we have ever known. Still, even this metropolis is not alone, for as vast as the Milky Way appears, it is but one galaxy among countless others, each with its own billions of stars and its own story of formation. Already you sense the next revelation waiting beyond the city limits, that our galactic home is just one member of a community, a local group bound together by gravity, adrift in the even larger ocean of the universe. The Milky Way, magnificent as it is, does not exist in solitude, just as no great metropolis can truly stand apart from its surrounding towns and cities. Our galaxy belongs to a broader family, an extended network of companions bound together by gravity across millions of light years. This is the local group, a collection of more than 80 galaxies sharing a common fate, drifting together through the immensity of the cosmos. Among these neighbors, one stands out above all the rest, the Andromeda Galaxy. Even to the unaided eye on a clear, dark night, Andromeda appears as a faint smudge in the constellation of the same name, a delicate wisp of light that looks almost accidental. Yet that soft blur, difficult to notice without intention, contains within it an empire of stars nearly unimaginable in scale. Roughly 1 trillion suns blaze within Andromeda's spiral arms, more than double the population of our own Milky Way. What you see as a fragile cloud is in truth a colossal city of light, so vast that its sheer enormity humbles the mind. The distances here stretch the imagination beyond comfort. Andromeda lies some 2.5 million light-years away. To translate, the light that now graces your eyes began its journey when early human ancestors on Earth were just beginning to master stone tools. By the time it arrived, generations had risen and fallen, civilizations had bloomed and faded, entire epochs had passed. When you gaze at Andromeda tonight, you are not seeing it as it is but as it was, a ghostly message delivered across time, a portrait from an age when humanity was still learning to survive. Numbers alone cannot capture this distance, so picture it instead with a metaphor. Imagine our galaxy, the Milky Way, scaled down to the size of a dinner plate resting on your table. On the other side of the room, about 20 feet away, another dinner plate sits, that is, Andromeda. Between them stretches empty floor, vast and unbroken. Within that room, scattered across the corners and tucked against the walls, sit smaller plates, saucers, and bowls, each representing the dwarf galaxies that make up the rest of the local group. Altogether, this room contains more than 80 galaxies, some large and bright, many small and faint, each a member of the same gravitational family. From our tiny vantage point within the Orion Spur, it can be easy to forget that such a family even exists, yet we are inseparably tied to its fate. What makes this relationship even more compelling is that these galaxies are not still. They are in motion, pulled by invisible threads of gravity, weaving paths that stretch across billions of years. Andromeda is not drifting away from us, but moving closer, barreling toward the Milky Way at a staggering 70 miles per second. Even at such speed, the gulf between us is so enormous that the two galaxies will not meet for another 4.5 billion years. But meet they will in a collision so vast that the word collision hardly seems fitting. Picture two immense spirals of stars, each with hundreds of billions of suns, drifting slowly into one another's embrace. When they meet, their delicate arms will tangle and warp, stars flung into new orbits like dancers pulled into a grand waltz. Despite the scale, the stars themselves will almost never collide, So much space lies between them that the galaxies will pass through each other like ghosts, yet gravity will reshape them. Over time, after repeated passes, the Milky Way and Andromeda will merge into a new form, a single, massive elliptical galaxy often nicknamed Milkomeda. It will glow brighter, larger, more radiant than either parent. This future, dramatic as it is, remains far beyond our personal horizon. By the time the merger begins, the sun itself will be entering its final stages of life, swelling into a red giant as it consumes its nuclear fuel. Earth may no longer be habitable, oceans boiled away, continents scorched. The dance of galaxies will unfold against a backdrop where our own familiar star has faded into its twilight. It is a reminder that cosmic time does not wait for us. It moves on scales so vast that entire epochs of life and death are only brief notes in its symphony. Still, knowing this destiny carries a strange comfort. We are not drifting alone, adrift in endless emptiness. The Milky Way is part of a family connected to Andromeda, Triangulum, and dozens of dwarf galaxies that swarm like satellites around their larger kin. The Triangulum galaxy, though smaller than either of its great neighbors, still contains tens of billions of stars, and it too may one day join in the merger dance. The Magellanic Clouds, visible from the southern hemisphere, are dwarf galaxies currently orbiting the Milky Way, their shapes stretched and distorted by our galaxy's gravitational pull. Even these tiny companions remind us that galaxies are not isolated islands, but participants in a larger, ongoing story. From another perspective, imagine once again shrinking the Milky Way to the size of a plate. In the room of galaxies that is the local group, most of the space remains empty. The vast stretches between the plates dwarf the plates themselves. To walk from one side of the room to the other would be to cross millions of light years. Yet within that emptiness lies connection, for the entire room is bound together by shared gravity, moving as one through the broader universe. The local group with its 80+ members is not static. It is on a journey of its own, being drawn toward an even larger structure, a gravitational hub beyond the room's walls. Seen from our vantage, the local group feels both intimate and overwhelming. It is intimate because, compared to the vast universe, it is only a small gathering of galaxies, a family cluster, not a metropolis of billions. Yet it is overwhelming because within it lies more stars than you could ever count, more worlds than you could ever imagine. 1 trillion in Andromeda, hundreds of billions in the Milky Way, tens of billions in Triangulum, each galaxy a sprawling stage where cosmic dramas unfold unseen. Every faint smudge of light captured by a telescope, every whisper of starlight crossing the abyss represents a member of this family. They are not just points in the sky. They are realms, histories, and futures woven together in the gravitational fabric of the local group. Yet as we lift our gaze beyond the room, the walls begin to fall away. The local group itself, impressive as it seems, is merely one room in an immeasurable mansion. For just outside its edges lies another cluster and another, gatherings of galaxies that together form the larger structures of the cosmos. The local group is only the beginning of a hierarchy, a building block in the architecture of the universe, drawn inevitably towards something even greater. The journey so far has carried us from our planetary backyard into the sprawl of galaxies that surround us. We've crossed the local group, drifted past Andromeda's looming presence, and lifted our perspective higher until even galactic neighbors resembled islands scattered across an ocean. Yet the further we zoom out, the more humbling the truth becomes. Galaxies themselves are not the final word in cosmic architecture. They are bricks in walls that extend across unfathomable distances, pieces of something grander, patterns stitched into the very skeleton of the universe. Begin for a moment with the Virgo cluster, a collection that reveals how galaxies rarely drift through the cosmos alone. Picture over 1,300 galaxies bound together, pulled into a gravitational embrace that spans nearly 15 million light-years across. From edge to edge, this single cluster dwarfs the local group we call home, reducing it to something like a tiny satellite town orbiting a great metropolis. To imagine its true immensity, think of the Milky Way, our spiral giant of 400 billion stars, then multiply it again and again until the mind begins to reel. Every smear of light, every elliptical haze in Virgo is itself a cosmic city of suns. This shift offers a vertigo of a different kind, not the shock of distance between stars or galaxies, but the realization that even galaxies are social creatures, woven into collectives that span millions of light years. Just as Earth is part of a solar system, and that system part of a galaxy, so too are galaxies members of these immense clusters. We are nested within structure after structure, like Russian dolls carved from gravity and light. But clusters, for all their scale, are not scattered randomly across space. They trace invisible patterns, forming filaments and threads that stretch across unimaginable distances. Astronomers sometimes call it the cosmic web, and the metaphor is apt. Imagine walking into a dark forest at dawn, where the morning dew clings to a spider's web stretched between branches. The droplets sparkle in the rising sun, each bead distinct yet connected by silken strands. Replace the forest with the void of intergalactic space, the dewdrops with galaxies, and the threads with rivers of dark matter and gravity. The picture is eerily similar. This web is not flat, but three-dimensional, strands looping and weaving in every direction, creating intersections where hundreds or thousands of galaxies gather into nodes. Between them stretch vast deserts of nothingness, cosmic voids so immense that they make even galaxy clusters seem like fragile ornaments dangling in a cathedral of emptiness. These voids are not simply empty of stars, but largely empty of matter itself, places where the expansion of space has swept galaxies away like leaves caught in a current. To truly feel the scale, step into the Laniakea supercluster, our home on this web. Only in 2014 did astronomers begin to map its extent, tracing how galaxies within it flow along gravitational currents, much like rivers feeding into a great basin. The word Laniakea comes from Hawaiian, meaning immeasurable heaven, and the name is well earned. Within this structure reside 100,000 galaxies, including our Milky Way, spread across a span of more than 520 million light-years. 500 million light-years across. A phrase that sounds impressive until you pause and remember what a single light-year is. The scale becomes so enormous that language begins to fracture and metaphor becomes the only bridge. If the Milky Way were a single grain of sand, then the local group might be a small pinch in the palm of your hand. The Virgo cluster would fill a bucket, heavy and overflowing. Laniakea, by contrast, would be a beach stretching beyond the horizon, a continent of sand that defies counting. Standing before it, one is struck not only by the numbers, but by the elegance of the structure itself, the way galaxies follow invisible filaments, clustering where gravity gathers, leaving voids as dark caverns in between. Yet even this titanic scale is not a final resting place for imagination. The cosmic web stretches further, linking superclusters into larger filaments that snake for billions of light-years. One of the longest identified is the Hercules Corona Borealis Great Wall, a filament so vast that it spans 10 billion light-years, 1/10 the size of the observable universe itself. To grasp this is to recognize that when we gaze into the night sky, we are not simply looking at scattered points, but at the tessellations of something far larger, a geometry of matter carved into existence by gravity and the expansion of space. It's humbling to realize that even the voids, the empty abysses between filaments, are essential to this grand architecture. They are not merely absences, but the other half of a balance. Without emptiness, structure would not stand out. Without the gravitational currents that swept matter into strands, The cosmos would be formless, a fog rather than a web. What we see then is not chaos but order, an order too vast to be fully drawn into the confines of human perception. From here, you might ask, what role do we play in this boundless lattice? Earth is smaller than a speck of dust compared to a supercluster, our lives briefer than a flicker of light. Yet here we are, able to map, to imagine, to see the web stretching across billions of light years. Our position is both minuscule and extraordinary, for though we occupy no privileged place in the fabric of space, we hold within us the privilege of perspective. As the mind lingers on this vision of the cosmic web, it is tempting to drift into abstraction, to see the universe as little more than geometry and voids. But each bead of light along those filaments holds stories, histories, and possibilities. 100,000 galaxies in Laniakea alone, each with its own spiral arms or elliptical haze, each with billions of stars, each star with the chance, however slim, of harboring planets where life has taken root. The web is not just structure, it is potential, a canvas not yet fully painted. The story of these great structures is still being written. With every new map, astronomers push the boundaries of what we can see, revealing larger and more intricate connections. The deeper we look, the universe resembles an organism, threads of matter pulsing with energy, voids like vast lungs expanding with every breath of cosmic time. It is a living architecture, one that challenges not just our sense of size, but our sense of belonging. We began this journey with the illusion that the moon hovered close enough to touch. We peeled back layer after layer until galaxies themselves became stepping stones on a lattice stretching for hundreds of millions of light years. Now, as you rest beneath your blanket of stars, you carry within your imagination the vision of that lattice, the grand cosmic web where clusters, superclusters, and voids weave together into something that defies even the boldest metaphor. The thread continues forward, pulling us to confront an even more profound horizon, the limits of what we can see at all. Beyond the strands of the web lies the observable edge, a boundary written not in galaxies but in time itself. As we drift toward that frontier, the question will not simply be how large, but how far back. For every step outward is also a step into history, into the beginning of light itself. The lattice of galaxies, filaments, and voids stretches outward in every direction, but even that grand architecture has its limits, not because the universe itself stops, but because our vision does. There is a horizon beyond which light has not yet reached us, a boundary painted not in walls of matter, but in the silence of time itself. To encounter it is to stand at the edge of knowledge, staring at the oldest light still whispering across the cosmos. That light is the cosmic microwave background, the faint afterglow of the Big Bang. It fills the sky in every direction, though our eyes cannot see it unaided. Sensitive instruments reveal it as a soft haze, nearly uniform, punctuated only by the slightest variations in temperature. These variations are fossils of the early universe, imprints of density fluctuations that would one day seed the formation of galaxies, stars, and planets. To gaze upon this light is to look back to a time when the universe was only 380,000 years old, when atoms first formed and the cosmos became transparent. Think of it as the universe's baby picture, a snapshot taken when the first photons were free to travel. Every time one of those photons reaches your eye, it tells you a story not of where it came from, but of when. This is the quiet miracle of light. It carries with it the memory of time. When you look at the moon, you see it as it was 1 second ago. When you turn a telescope toward Andromeda, you are seeing starlight that left its spiral arms more than 2 million years ago. Push deeper, and the scale stretches further. Some of the galaxies we observe today are as they were when dinosaurs roamed the Earth. Others send us light that departed before Earth even existed, long before our sun ignited. The night sky is not a still painting but a time machine. Each star and galaxy a delayed broadcast from the past. Even the faintest smudge recorded by the Hubble Deep Field is a message across billions of years. In those ghostly streaks, we do not see galaxies as they are, but as they were, caught in stages of growth, collision, and transformation. To look outward is always to look backward, to trade distance for history. This interplay between light and time shapes the very idea of the observable universe. We do not sit in the middle of everything by privilege, but by geometry. Light radiates toward us from every direction, forming a cosmic sphere. At its edge lies the microwave background, 13.8 billion years distant in time. Yet the expansion of space means those ancient photons began their journey from regions now far beyond that distance. The true radius of the observable universe is not 13.8 billion light-years, but closer to 46 billion. Multiply that diameter, and you arrive at a sphere 93 billion light-years across. That is our cosmic horizon, the greatest extent of what can be seen, not of what exists. Within this boundary, astronomers estimate, reside 2 trillion galaxies. The number strains comprehension. Imagine every galaxy as a city, each filled with billions of suns. The observable universe becomes a continent without end, a mosaic of possibilities too vast for any one mind to fully contain. And still, this is only the part revealed to us. The universe beyond may stretch infinitely, or it may curl back upon itself, hidden from view. What we see is not the whole, but a bubble of awareness limited by time's patient march. It is difficult to sit with numbers so immense without anchoring them in metaphor. Suppose the Milky Way were reduced to a single grain of sand. To represent every galaxy in the observable universe, you would need enough sand to fill all the beaches on Earth, from the white shores of the Caribbean to the storm-lashed coasts of the Pacific. Each grain would hold hundreds of billions of stars, each star perhaps with its own family of planets. The sphere of 93 billion light-years becomes a beach without end, stretching past every horizon the imagination can build. Yet this horizon carries with it a quiet poignancy. Those photons we see from the microwave background have been traveling since the dawn of time, but there are regions whose light has not had enough time to reach us at all. There are galaxies forever beyond our sight, receding faster than the speed at which light can bridge the distance. Their stories are written into the universe, but they will never be written into ours. The observable boundary is not just a limit of distance, but a curtain of ignorance, a reminder that the cosmos is always larger than our ability to grasp it. Still, even within that curtain, the richness is overwhelming. Each photon collected by a telescope carries the weight of a journey billions of years long, slipping between galaxies, traversing voids, surviving collisions and expansions. By the time it brushes against a detector, it has already lived an odyssey greater than anything on Earth. To study that light is to become an archaeologist of time, sifting through relics older than mountains, older than oceans, older than the very elements in our bodies. There is also a strange intimacy in the fact that no matter where in the universe an observer might stand, on a planet circling a distant star, or in a galaxy we can only imagine, they too would find themselves at the center of their own observable sphere. Each perspective carves a bubble into the fabric of time, with the microwave background at its edge. We are not special in placement, only in perception. The universe grants this privilege to every observer, a democratic scattering of horizons across infinity. To carry this thought further is to encounter a tension between humility and wonder. We are small, impossibly small, living within a boundary that itself is only a fraction of reality. Yet we are also the creatures who can trace that boundary, who can look into the faint glow of the microwave background and understand that it is the afterglow of creation itself. Our limits do not diminish us, they define the shape of our knowing. The observable universe, then, is both a map and a mystery. It tells us what we can see, but it whispers of what lies beyond, hidden in the regions where light will never reach us. To step into this awareness is to feel both awe and longing, awe at the immensity of what is revealed, longing for the parts forever out of reach where the story continues without our eyes to witness it. As the mind drifts on this horizon, it feels almost like standing at the edge of an ocean at night. The waves crash against the shore, each one a photon arriving after a journey through time. Beyond the dark line of the sea lies more ocean, endless and unseen. You know it is there, yet you cannot touch it. The horizon is both boundary and promise. From here the path forward leads not to larger distances but to deeper mysteries. For if the observable universe marks the edge of sight, then the question turns to what gave rise to that light in the first place. What is the origin of time's arrow, the spark from which the cosmos expanded? To follow that thread is to move from horizon to genesis, from the faint glow of the afterglow to the unimaginable fire that came before. The afterglow of the Big Bang forms a boundary we cannot look beyond, a veil of light stretched across the sky like the walls of a great dome. Yet that dome is not the edge of reality, only the edge of what light and time have allowed us to see. Step back in imagination, and the humbling truth emerges. The observable universe may be only a tiny fragment of a far larger whole. Astronomers, using the laws of physics as their compass, suggest that what we see is a pinhole view through an endless expanse. If the observable sphere is 93 billion light-years wide, the true universe could be at least 250 times larger, so vast that the word larger hardly feels sufficient. There may be no edge at all. Infinity could lie beyond the horizon, stretching into a reality that continues without limit, a canvas with no frame. To glimpse how such immensity could arise, we must return to the universe's first instant, the inflationary epoch. For the briefest fraction of a second after the Big Bang, space itself expanded at a pace so furious that it makes light look sluggish. This expansion was not of objects moving through space, but of space itself ballooning outward, doubling and doubling again in a runaway process that ironed the cosmos flat and uniform. Imagine a balloon inflating faster than you can blink, so quickly that points once close become forever separated, pulled beyond each other's reach before any signal could bridge the gap. That primordial inflation explains why the microwave background is so smooth, why distant regions look alike despite never having been in contact. It also explains why the observable universe may be such a small portion of the whole. Inflation carried vast regions away from us, so far and so quickly that their light will never reach us, no matter how long we wait. They are exiled beyond communication, lost not by distance alone but by the very rules of space-time. Picture the observable universe as a single glowing bubble suspended in darkness. Inflation suggests that beyond this bubble lies another, and beyond that another still, a froth of universes budding from the same primordial expansion. Each bubble contains its own galaxies, its own stars, its own patterns of matter and void. Some may resemble ours, others may be utterly alien, shaped by physical laws subtly or drastically different. Perhaps in one, gravity is weaker, and stars never ignite. Perhaps in another, galaxies form more quickly, and life blooms on countless worlds. This vision is not idle fantasy, but a natural consequence of the mathematics of inflation. If space inflated once, why not countless times? If bubbles can form, why only one? The universe begins to resemble a cosmic foam, each pocket isolated, each with its own horizon, each inhabited, possibly, by beings staring into their sky and wondering whether what they see is the whole. Our own observable sphere is but one island in an endless archipelago, a shoreline we mistake for the continent. It is unsettling to imagine that our grandest maps, stretching to 93 billion light-years, are little more than sketches of our neighborhood. The true geography of the cosmos may remain forever beyond us, unseeable, unmeasurable. Yet there is a strange comfort in this too. Infinity is not something to conquer, but something to dwell within, a reminder that no matter how far our instruments reach, mystery will always lie ahead. Consider for a moment the silence of those unreachable regions. Somewhere beyond our horizon, galaxies speed away so quickly that no photon they emit will ever cross the gulf. To us they are invisible, but invisibility does not mean absence. Their stars burn, their planets orbit, their light streams outward, yet it is light destined for no eyes, falling forever into the expanding dark. To those hypothetical observers out there, we are the ones who are invisible, our Milky Way hidden beyond their curtain of time. The symmetry of this realization is striking. Every bubble of awareness in the cosmos is both complete and incomplete. Each sits at the center of its own horizon, yet none can see beyond. The universe is democratic in its mysteries. No vantage point grants the whole picture. Perhaps that is the universe's quiet joke. To every observer, it grants the illusion of centrality while keeping its true immensity hidden. For us, this means our maps are necessarily parochial. We can chart the galaxies within our sphere, trace the filaments of the cosmic web, measure the faint glow of the microwave background, but beyond, there may be more of the same, or not. There could be structures so colossal they make Laniakea look like a grain of sand. There could be variations in the very fabric of physics, regions where constants we consider fixed take on new values, rewriting the rules of matter and energy. We cannot know. Our horizon is both a gift and a wall. To reflect on this is to feel both dwarfed and exalted. Dwarfed because our cosmos is only a patch in a quilt too vast to fold into thought. Exalted because within this tiny patch consciousness has arisen, capable of wondering, capable of asking what lies beyond. No galaxy, no cluster, no supercluster can do this. Only minds, fragile and fleeting, carried on a small planet orbiting an unremarkable star. Inflation also raises an even deeper possibility that the bubbles of reality are not simply far apart, but truly infinite in number. An eternal inflation would generate pocket universes endlessly, each one birthing another horizon, each with its own physics, its own histories, its own potential for life. In this view, our observable universe is not just one island in a cosmic ocean, but one among an infinite archipelago scattered across a sea without end. The thought is dizzying. Somewhere, perhaps impossibly far away, another version of you might be staring at their own night sky, wondering the same questions. Or perhaps not. Perhaps their universe followed different rules, and their stars never formed, their atoms never combined. Infinity leaves room for all possibilities, yet confines each within its bubble. As you lie beneath your own sky tonight, think of this. The starlight that reaches you is a gift from a universe you can see, but beyond that glow lies an expanse that will be laid. To step into that moment is to seek not the edge of the universe, but the spark of its birth. Beyond the horizon, the mind reels with images of infinite bubbles, universes without end. Yet to step further into the mystery, the journey must turn inward, away from the incomprehensible vastness of galaxies and clusters, down to the tiniest building blocks that make all of it possible. The grandest scales of reality are sustained by the smallest, atoms, particles, quarks, and perhaps something even deeper, where the fabric of space and time themselves begins to dissolve. Imagine zooming inward from a galaxy to a star, from a star to a planet, from a planet to a grain of sand. Then imagine continuing the descent, not stopping at the level of molecules or even atoms, but diving into the nucleus, then further still, until all familiar notions of solidity vanish. What once seemed like matter reveals itself to be patterns, fields, probabilities. Beneath every chair, every rock, every human hand lies an ocean of quantum uncertainty, where particles flicker in and out of existence, where emptiness itself teems with activity. Consider your own body. Every atom within you is ancient, forged long before you were born. The hydrogen in your veins was created during the first minutes after the Big Bang, when the infant universe cooled enough for protons and electrons to form the simplest element, the oxygen you breathe, the carbon that forms your cells, the calcium in your bones, all were born in the furious cores of stars. When those stars exhausted their fuel and collapsed, their explosive deaths scattered the raw materials of life into space, to drift, to gather, to become the clouds that birthed new suns and worlds. In a very real sense, you are a collection of stardust given shape, a fleeting pattern of atoms arranged into awareness. But even atoms are not the bottom of the ladder. They are composed of protons and neutrons, which themselves are made of quarks bound by the strong nuclear force. Electrons orbit, but not in neat planetary paths, rather in clouds of probability, shimmering regions where existence is a question more than a certainty. At this scale, reality resists the images our brains cling to. To see an atom is not to see a solid bead of matter, but to glimpse a dance of energy where boundaries blur and certainty dissolves. As we descend further, we approach the limits of measurement. The Planck scale, about 10⁻35 meters, represents the frontier where our concepts of distance and time begin to fracture. At this unimaginably small scale, the smoothness of space-time that Einstein described in his equations may not hold. Instead, it may froth and churn like an ocean surface under storm, a quantum foam where geometry itself is uncertain, where the notions of before and after, here and there, no longer make sense. It is here that a profound possibility emerges, that space and time are not fundamental but emergent. Just as temperature is not a property of a single molecule but of many molecules moving together, so too might space-time itself arise from something deeper, patterns of information, entanglement between particles, or principles yet to be discovered. If true, then everything we experience, location, duration, motion, may be secondary effects, shadows cast by a reality more basic. One of the most astonishing windows into this mystery comes from black holes. These objects, where gravity is so extreme that nothing, not even light, can escape, seem to suggest that the information contained within a region of space is not determined by its volume, but by its surface. This realization gave rise to the holographic principle, the radical idea that all the information in a three-dimensional space can be encoded on a two-dimensional boundary. Imagine a hologram etched onto glass. The surface holds the information, yet when lit, it produces the illusion of depth. In much the same way, our reality may be the unfolding of information stored on a cosmic horizon. Think of it this way. Everything you see, feel, and know could be the projection of information encoded on a boundary far removed from you. The floor beneath you, the walls around you, the stars in the sky, each might be emergent, the way a three-dimensional image emerges from a flat hologram. The world feels solid and immediate, but beneath it may lie a lattice of encoded bits, far stranger than our senses can grasp. This idea is not idle speculation. It arises from attempts to reconcile two of the greatest frameworks of physics, Einstein's general relativity, which describes the smooth curvature of space-time, and quantum mechanics, which reveals the jittery, probabilistic nature of particles. At their intersection, paradoxes bloom. Black holes, for example, seem to swallow information in a way that breaks the rules of quantum theory. The holographic principle offers a bridge, suggesting that no information is truly lost, only hidden or transformed, inscribed on the boundaries of space-time itself. If reality is holographic, then the universe is not quite what it seems. Distance may be an illusion, space a tapestry woven from correlations rather than true separations. Entangled particles already hint at this, their states linked across vast spans in ways that defy classical explanation. Perhaps such connections are not anomalies, but clues to a deeper unity, a reality in which separateness itself is a convenient fiction. Imagine then that what we call here and there are not absolute but contextual. The quantum foundation suggests that existence is relational, woven from interactions rather than objects, from probabilities rather than certainties. The cosmos, at its most basic, may be a network of information flickering between states, a kind of universal computation whose output is what we perceive as stars, galaxies, and life. This perspective reshapes the question of scale. The universe is vast, yes, but its vastness is sustained by rules, written at scales far below what eyes or telescopes can detect. The immensity of clusters and voids is possible only because of the jitter of quarks and the dance of electrons. Infinity itself is built atop the strange, the fleeting, the quantum. The electromagnetic force, if altered by a fraction, would prevent atoms from holding together or molecules from forming the intricate chains necessary for biology. The cosmos plays its symphony on a piano where each key must be tuned exactly, not approximately, to sustain the melody of existence. Visualize such a piano, a long stretch of ivory and ebony, each key representing a constant of nature. Strike a key that is too sharp or too flat, and the harmony collapses. The stars no longer shine, or chemistry cannot exist, or space itself tears apart before galaxies can gather. Yet on this impossibly delicate instrument, the universe plays with perfect pitch, each constant aligned so that matter condenses, stars ignite, planets cool, and living cells assemble. The odds of such tuning boggle the imagination, yet here we are, listening to the music, part of the song itself. The more one considers this, the more profound the implications become. Perhaps these constants are simply given, immutable facts of existence. Perhaps they arise from deeper principles yet to be discovered, rules that determine their values as inevitably as arithmetic produces its sums. Or perhaps, and this is where philosophy enters, there are countless universes, each with its own set of constants, most sterile, some short-lived, only a rare few capable of producing observers. In this view, we find ourselves in a universe suited for life not because of chance, but because only in such a universe could observers ever ask the question. This is the heart of the anthropic principle, the recognition that our ability to ponder existence is itself evidence of the conditions required for that pondering. It is not so much a solution as a reflection, a tautology that reframes the enormity of reality. We exist in a universe that allows observers, because only in such a universe could observers exist. The statement seems circular, yet it illuminates why the cosmos, so vast and precise, carries meaning beyond its mechanics. Imagine a barren universe where constants are tuned differently. Stars might never ignite, or they might flare briefly and vanish. Chemistry could be impossible, atoms too unstable to form the scaffolding of complexity. In such universes, silence reigns. No planets orbit in gentle rhythms, no rivers carve landscapes, no eyes open to witness the stars. There is light, perhaps, and expansion, but no story, no reflection. We cannot inhabit those universes because they offer no stage for inhabitation. Instead, we find ourselves in this one, this unlikely balanced cosmos where stardust breathes and wonders about its origin. The scale of precision is staggering. Physicists estimate that if the expansion rate of the universe 1 second after the Big Bang had been different by even 1 part in 10^14, the cosmos would have either collapsed back into itself or expanded too quickly for galaxies to form. The gravitational constant, if shifted by a fraction of a percent, would have doomed stars from the start. These are not wide margins. They are razor-thin tolerances on which hangs the possibility of life, thought, memory, and story. The symphony of existence plays on an instrument tuned with impossible care. This perspective does not diminish science but deepens it. Each discovery about particle masses, nuclear reactions, or cosmic expansion carries with it a recognition of how fragile and specific the balance is. To study physics is not merely to measure, it is to glimpse the improbability of being, to touch the scaffolding that makes thought possible. When we measure the constants of nature, we are measuring the keys of the piano that allowed stars to burn long enough for carbon to crystallize into the forms that would one day write equations and sing songs. Yet the anthropic principle is more than numbers. It touches the heart of meaning. If the universe is tuned for life, then our presence is not incidental. We are woven into the story the cosmos tells. Whether or not there are other universes, whether or not life is abundant elsewhere, the fact that life exists here and now is a testament to the profound alignment of conditions. To exist is to bear witness to the precision of reality, to feel within one's own breath the improbable success of countless balances that might have tipped another way. Consider again the metaphor of music. The universe is not a single note but a symphony. Stars as chords, galaxies as harmonies, life as melodies rising above the background hum. Each note depends on tuning, each instrument on structure. Remove a single string or alter a pitch, and the music changes beyond recognition. Yet here, in this cosmos, the song plays on, carrying within it not only light and matter, but also curiosity and awareness. The music does not simply surround us. We are among its instruments, adding our own notes to the cosmic score. From this vantage, the question shifts. Instead of asking why the universe allows life, one might ask what role life plays within the universe. Perhaps we are not merely accidental byproducts, but integral to the unfolding, the cosmos, becoming aware of itself through the eyes and minds of observers. The anthropic principle, then, is not only a statement of necessity, but also a suggestion of purpose, however subtle. This idea leads naturally toward the mystery of consciousness, of mind. If the universe is tuned to allow life, then life is tuned to allow awareness, perception, reflection. The journey from stardust to self-awareness is long, but it is inseparable from the balance of forces that govern every star and particle. To explore this is to walk the threshold between physics and philosophy, between what can be measured and what must be contemplated. As the story continues, we will follow this path deeper into the nature of consciousness itself, into the mystery of why awareness arises from matter at all. If the universe is a stage, finely balanced and immense, then consciousness is the play unfolding upon it, ephemeral yet profound. The next act will lead us into this enigma, where physics meets mind and the cosmos looks back upon itself through human thought. If the universe were a vast book, its pages stretching across billions of years, our story would occupy not even a sentence but the final punctuation mark at the edge of a line. Carl Sagan offered a metaphor that brings this truth into focus. Compress the entire 13.8 billion year history of the cosmos into a single calendar year, and you will see just how late we have arrived to the cosmic stage. On this scale, the Big Bang erupts at midnight on January 1st, a burst of unimaginable energy giving rise to space, time, and the first particles. By late January, the first galaxies coalesce, swarms of stars lighting up the dark. Spring arrives, but entire epochs pass before complexity builds. Only in September does our own sun ignite, a relatively young star born in the swirling arms of the Milky Way. Earth itself forms shortly after, around September 21st, with the earliest hints of life appearing by late September. For the next 3 cosmic months, evolution unfolds in microscopic whispers: bacteria, archaea, single-celled organisms slowly shaping the planet's atmosphere. Multicellular life does not appear until early December. Dinosaurs stride across the stage on December 25th, only to vanish by December 30th. Then, in the final hours of December 31st, mammals flourish, primates rise, and finally, in the last minute of the last day, humans carve their fragile mark. Civilization as we know it, the building of cities, the rise of agriculture, the shaping of language, music, philosophy, and science, emerges not in the final minute but the final seconds. All of recorded human history is contained in a breath at 11:59:48 p.m., a mere 12 seconds before midnight. From pyramids to smartphones, from fire to fusion, the entire span of human endeavor fits in the faintest flicker on the clock. The cosmic year reminds us that while the universe has had aeons to evolve, we are newcomers, recent arrivals at a feast that began long before us and will continue long after. To appreciate this calendar is to feel both humbled and strangely privileged. We are latecomers, yes, but we arrived at just the right moment. Too early, and the elements needed for life would not yet exist. Too late, and the best ages of star formation might have already passed. We live in the luminous prime of cosmic history, when galaxies blaze with countless suns and the night sky still sparkles with abundance. But how did we arrive here, on a planet of metals and water, in bodies made of carbon and oxygen, in a cosmos where hydrogen once reigned supreme? The answer lies in the generations of stars. The very first stars, born shortly after the Big Bang, were titans. They were forged almost entirely from hydrogen and helium, the lightest and simplest elements produced in that initial fireball. These first-generation stars lived brief, violent lives. With no heavier elements to temper their reactions, they burned furiously and perished quickly, collapsing into black holes or exploding as supernovae. Their deaths, though destructive, were also creative. In their fiery cores, through the fusion of nuclei, they forged heavier elements, carbon, nitrogen, oxygen, iron, scattering them into the cosmos with their final breaths. Second-generation stars gathered this stardust, incorporating heavier elements into their structures, and in turn, they too lived and died, spreading even more complexity into the galactic medium. By the time our sun was born 4.6 billion years ago, the universe had already been enriched by countless stellar deaths. We are children of third-generation stars, our world shaped from the ashes of suns that lived and died long before. Every atom of iron in your blood, every calcium atom in your bones, every carbon atom in your DNA was once forged in the core of a star and cast across space in a supernova. To look in a mirror is to see the afterlife of ancient suns staring back. This recognition binds us to the cosmos in a way few metaphors can capture. We are not separate from the universe but made of it, not visitors to the cosmos but participants in its very unfolding. The cosmic calendar reminds us how late we arrived, but stellar generations remind us that we could not have arrived any earlier. Life requires the universe to age, to burn through cycles of creation and destruction until the ingredients for complexity are plentiful. Our lateness is not an accident but a necessity. Yet even with all this history, the universe remains astonishingly young. 13.8 billion years may seem like an eternity, but compared to what lies ahead, it is merely the opening act. Stars will continue forming for trillions of years, long after our sun has burned out. Galaxies will shift, merge, and transform. Civilizations, whether ours or others, might rise and fall countless times over before the great engines of starlight finally dim. Imagine the deep future, a universe tens of trillions of years old, where red dwarf stars, the slowest burning of them all, still glow faintly. These stars live for hundreds of billions, even trillions of years, outlasting the bright giants by unimaginable margins. Around such stars, planets may still orbit, warmed gently by their patient embers. Life, perhaps, could still emerge in that distant age, long after our sun has faded to a white dwarf and our planet has crumbled into silence. This perspective is both haunting and liberating. On the cosmic calendar, we are still in January of the universe's great story. Almost everything lies ahead. The epochs we call ancient, dinosaurs, pyramids, empires, are not even footnotes in the broader sweep of cosmic time. We are witnesses to the youth of the universe, gazing out into its morning sky. To compress billions of years into a single year is to glimpse both the brevity of our existence and the immensity of what surrounds it. Our civilizations may last only seconds in the cosmic calendar, yet within those seconds we have looked back across the months, reconstructing history from light that has traveled for billions of years. We are newcomers who, almost immediately upon arrival, began to study the banquet hall, asking not only how it was prepared, but why we find ourselves here to witness it at all. Such questions draw us toward the horizon of the future, into the possibility that the universe's story is not merely about matter and energy, but also about meaning, awareness, and the unfolding of consciousness within time. If the past has been shaped by stars and galaxies, the future may be shaped by minds, human or otherwise, reaching out across the eons. The cosmic calendar places us at midnight on December 31st, but it also reminds us that the next year has yet to be written. The narrative now leads us deeper into that unfolding, toward a reflection not just on when we exist, but on why consciousness has emerged at all and what it means for the universe to be aware of its own youth. If the universe is as vast as we now know it to be, brimming with trillions of galaxies, each holding billions of stars, many of those stars hosting planets in stable orbits, then a simple question presses at the edge of thought. Are we alone? The numbers suggest otherwise. The probabilities lean toward abundance, yet, as far as we can tell, silence reigns. The night sky, for all its glittering promise, has not yet answered back. To frame the mystery, astronomer Frank Drake proposed an equation, not so much a calculation as a meditation. The Drake equation asks us to multiply together a chain of probabilities, the rate of star formation in our galaxy, the fraction of those stars with planets, the number of habitable worlds per planetary system, the fraction on which life arises, the fraction where life evolves intelligence, the fraction of intelligent life that develops detectable technology, and the length of time such civilizations broadcast their presence. Multiply these factors and you arrive at a number that represents the possible civilizations in the Milky Way. When Drake first presented his equation in 1961, many of the variables were guesses. Today, some of those uncertainties have narrowed. We know that planets are common. On average, there are more planets than stars. We know that many stars host worlds in the habitable zone where liquid water might exist. The conditions for life, it seems, may not be rare. If even a small fraction of habitable planets develop biology, the galaxy could be teeming with living worlds. If a smaller fraction still evolves intelligence and technology, then the Milky Way alone might host thousands of civilizations. Extend this calculation beyond our galaxy to the observable universe's 2 trillion galaxies, and the numbers spiral into near certainty. Life should be out there. Intelligent life should be out there. Advanced civilizations should, by all rights, be as common as stars themselves. Yet we see nothing. This silence is crystallized in what physicist Enrico Fermi once asked over lunch in 1950. Where is everybody? If the cosmos is old and vast, civilizations should have had ample time to arise, expand, and leave traces. Some might span star systems, others entire galaxies. If even a handful had developed technologies millions of years ahead of us, their presence should be detectable in starlight, in energy signatures, in whispers across the electromagnetic spectrum. Yet despite decades of listening, we have heard no clear signal, no beacon, no undeniable trace of intelligence beyond our own. This puzzle is called the Fermi paradox, and its implications are profound. Perhaps civilizations are rare, life itself a fragile fluke. Perhaps intelligent life is common but short-lived, destroyed by self-inflicted catastrophes or natural disasters before spreading beyond its cradle. Perhaps advanced beings choose not to reveal themselves, observing from a distance or cloaking their presence deliberately. Or perhaps the paradox reflects not the rarity of others but our limitations, our instruments too crude, our methods too narrow, our timescale too short to glimpse the long-lived symphony of interstellar civilizations. The paradox unsettles because it forces us to confront not only the possibility of cosmic loneliness, but also the fragility of our own future. If civilizations tend to vanish quickly, what does that say about us? Are we at the threshold of becoming one of countless sparks that flickered briefly in the dark? Or can we endure long enough to light the galaxy with our presence? Yet for all its silence, the search continues. Projects like SETI, the search for extraterrestrial intelligence, have scanned the skies for decades, listening for patterns in radio waves that might betray an artificial origin. The effort is patient, methodical, and humbling. Imagine pointing your antenna at a star 100 light years away. If a civilization there sent a message at the time when Charles Darwin was writing about evolution, we might be receiving it only now. By the time we replied, another 100 years would pass, and if they answered again, another 100. A conversation would take centuries to exchange even a few lines. Contact across interstellar distances is not a dialogue, but a correspondence written in slow motion, like messages carved into stone and left for future generations to uncover. In recent years, initiatives like Breakthrough Listen have expanded the effort, using some of the world's largest radio telescopes to survey millions of stars across wide swaths of the electromagnetic spectrum. The sensitivity of these instruments is staggering. They could detect a transmitter no more powerful than a typical airport radar from hundreds of light years away. Yet the silence persists. Each year of listening adds to the mystery, not just by failing to reveal others, but by deepening our awareness of just how alone we appear to be. This silence is not emptiness, though. It carries meaning of its own. It reminds us that even in the absence of signals, the cosmos is alive with possibility. Every new exoplanet discovered is another candidate for life. Every survey of the sky refines our understanding of where, when, and how to listen. The search is not merely about finding others, but about expanding the boundaries of our curiosity. It is an act of hope as much as an act of science. Picture the poignancy of success. Suppose tomorrow we detect a narrow-band radio signal pulsing from a star 1,000 light years away. It would not be a greeting in the ordinary sense, but an echo from a civilization that sent it long before our species invented printing presses or telescopes. That civilization might still exist, or it might have vanished centuries ago. The message would be less a conversation than a monument, a testament carved into the fabric of space-time that says simply, "We were here." Such a discovery would change everything, even if no reply were possible. It would affirm that intelligence is not unique to Earth, that mind is a cosmic phenomenon as much as matter and energy. It would bind us to others across the gulf of time, reminding us that we are part of a wider story whose chapters remain unwritten. In the meantime, the Fermi paradox remains. The silence persists, yet silence is not proof of absence. It may be that we are listening at the wrong frequencies, or that advanced civilizations communicate in ways we cannot yet imagine, using neutrinos or quantum entanglement or channels of physics we have not yet uncovered. Or perhaps they are waiting, allowing young civilizations like ours the dignity of discovering the cosmos for ourselves. To ponder this is to feel both the loneliness and the promise of the night sky. We may be alone, or we may be surrounded by others whose voices we have not yet learned to hear. Either way, the act of listening binds us to the universe in a unique way. It says that we are not only aware of the cosmos, but also seeking connection within it. The search for others is, in truth, a search for ourselves, for our future, for our potential, for the meaning of intelligence in a universe vast enough to cradle endless possibilities. The story leads us now from the silence of the stars toward the reflection that silence evokes, the nature of intelligence itself, its fragility, its resilience, and its role in shaping the destiny of life in a universe still young. From the silence of the stars, our gaze turns inward once more to the foundation of what the universe truly is. Beneath matter and energy, beneath space and time themselves, a deeper possibility emerges, one that reframes existence not as a dance of particles or a stretch of fabric, but as a tapestry woven from information. In this view, the universe is not merely made of stuff, it is a vast computational process, unfolding in patterns of logic and code as ancient as the cosmos itself. To grasp this perspective, imagine stripping away the material forms around you, the chair you sit in, the air you breathe, even the atoms of your body. At the most fundamental level, what remains is not solid matter, but arrangements of states, electrons that can be here or there, spins that can be up or down, photons that can exist or vanish. Each of these states carries information, a binary whisper of presence and absence. Just as a computer processes zeros and ones to generate images, sounds, and worlds of its own, so too does the universe compute reality by updating its information from moment to moment. This is the heart of digital physics, the bold idea that the universe is, in essence, a vast information processing system. Every interaction between particles is a calculation. Every law of physics is an algorithm. The expansion of the cosmos itself can be seen as a program running forward, one tick of the universal clock after another. The galaxies wheeling across the heavens are no less real for being computations. Rather, they are the grand output of a cosmic processor whose scale defies comprehension. If this seems abstract, consider how deeply information already underlies our sciences. Thermodynamics, once the study of heat, revealed its connection to entropy, an arrow of disorder measured in bits of information. Quantum mechanics, once a bewildering field of probabilities, now describes particles as carriers of information, entangled in ways that suggest reality is less about what things are than about what they know about one another. Even black holes, once imagined as simple cosmic vacuums, now appear as storage devices of staggering capacity, their horizons encoding every detail of what falls within. Everywhere we look, the language of information whispers through the equations. Yet even if the universe is a computational engine, it is not without boundaries. Just as your laptop cannot run infinitely fast or store unlimited data, so too does the cosmos impose limits on information processing. One such constraint is the Landauer limit, a principle discovered in the mid-20th century. It states that erasing a single bit of information, resetting a 1 to a 0, requires a minimum amount of energy. This ties information not just to logic, but to the very fabric of thermodynamics. Every act of computation has a physical cost, a price paid in heat. Other limits arise from relativity and quantum theory. The speed of light sets a maximum rate at which information can travel from one point to another. No message, no calculation, no signal can outpace this universal speed limit. Meanwhile, quantum mechanics ensures that information cannot be copied perfectly, nor erased completely, a rule known as the no-cloning theorem. Together, these boundaries define the contours of what the universe can compute. Even the cosmos, in all its immensity, cannot transcend the laws that govern information itself. This leads to astonishing conclusions. Physicists have calculated that any finite region of space contains a maximum amount of information, proportional not to its volume, but to the area of its boundary. This insight, echoing the holographic principle, suggests that reality is not an infinite reservoir of detail, but a finite ledger of information, processed and updated within strict limits. The stars above, the atoms below, the thoughts within your mind, all of it unfolds within a bounded computational capacity, as though the universe were both stage and processor for the play of existence. Once we glimpse reality this way, an unsettling but compelling question arises. If the universe operates like a computation, could it literally be one? This is the essence of the simulation hypothesis, the proposal that our cosmos might be an artificial construct, a virtual reality created by an intelligence far beyond our own. It is tempting to dismiss the idea as science fiction, but serious thinkers have given it careful attention. Consider the trajectory of our own technology. In a few decades, we have built machines capable of simulating weather systems, ecosystems, even fragments of entire universes governed by the laws of physics. Our video games already host worlds so rich that millions of people inhabit them daily, their avatars governed by algorithms that mimic reality. If our progress continues, there may come a time when we can simulate entire histories, complete with conscious beings who believe themselves to be real. If we can imagine creating such simulations in our future, what prevents us from considering that others, civilizations far older, far more advanced, might have already done so? If the cosmos is ancient and intelligence long-lived, perhaps our reality is not the original, but one of countless simulations running on unimaginable substrates. Perhaps our stars are rendered, our atoms updated by cycles of computation, our very thoughts patterns in a cosmic program. The simulation hypothesis is not easily testable, but it offers a framework for startling possibilities. Some argue that subtle glitches in the laws of physics, tiny anomalies in the fabric of space-time, or unexplained patterns in cosmic background radiation might someday reveal the fingerprints of an underlying code. Others suggest that if the resolution of the universe is finite, like pixels in a screen, we might one day find the smallest unit, the indivisible voxel of space-time that betrays our simulation's architecture. Still, whether or not the hypothesis is true, its contemplation reshapes our sense of meaning. If we are in a simulation, then our existence is not diminished but reframed. We would still be real to ourselves, our joys and sorrows genuine, our choices significant within the structure we inhabit. The program would not erase our humanity, it would underline it, casting us as conscious participants in a greater design. More provocatively, the simulation hypothesis invites us to consider what kind of beings might create such a universe, and for what purpose. Would it be curiosity, an experiment in cosmic history? Would it be art, a creation of beauty and narrative? Would it be necessity, an archive to preserve knowledge against the entropy of a dying cosmos? Or would it be something beyond our imagining, motives as alien to us as our own are to the ants beneath our feet? The idea also turns inward, reflecting not just on the possibility of being simulated, but on the inevitability of becoming simulators ourselves. If we endure long enough, if our technology matures, we too may construct universes within machines, spawning realities where life unfolds unaware of its origins. In doing so, we would mirror the very question we now ask: what is real, and how deep does the recursion go? All of this brings us back to the central theme: information as the bedrock of reality. Whether or not we are in a simulation, the universe behaves as though it were computational, every law reducible to patterns of bits and logic. Information is conserved even when matter collapses into black holes. Information defines the entropy of galaxies, the states of atoms, the entanglement of quanta across light years. To understand the universe may ultimately mean to understand information, not as a tool we use, but as the very substance of existence. The path forward leads us deeper still into the interplay between information and meaning, between computation and consciousness. If the cosmos is a grand processor, then minds like ours may be both outputs of its calculations and instruments for decoding its secrets. The question is no longer only whether the universe computes, but whether it thinks, and whether intelligence, ours or another's, is woven into its fabric as naturally as gravity and light. Beyond the familiar glow of stars and galaxies, beyond the atoms that compose mountains and oceans and bodies, lies the vast unknown. We once thought the universe was made mostly of what we could see: planets, stars, gas, dust. But now we know that all of this, everything luminous and tangible, accounts for less than 5% of the cosmos. The rest is something else entirely: dark matter and dark energy, invisible yet overwhelming, constituting the great majority of existence. Dark matter reveals itself not through light, but through gravity. Galaxies spin too fast for their visible stars to hold together. Without an unseen mass binding them, they would fly apart. Clusters of galaxies bend the light of background objects more than ordinary matter could explain, as though they were wrapped in hidden scaffolding. This unseen component outweighs the matter of stars and planets 5 to 1, filling halos around galaxies, shaping the large-scale structure of the cosmos, guiding the dance of light we mistake for the whole. Yet despite decades of searching, no one knows what dark matter truly is. It passes through our bodies by the trillions each second, invisible, silent, indifferent to ordinary matter, except through the tug of gravity. It is the ghostly stage upon which the luminous actors of the universe perform. If dark matter is the scaffolding, dark energy is the dynamo. Discovered at the close of the 20th century, it is not matter at all, but a property of space itself, a mysterious pressure that drives the expansion of the universe to accelerate. Where once we thought gravity would slow the cosmic expansion, perhaps even halt it, we now know the opposite is true. Space is stretching faster and faster, carrying galaxies away like driftwood on a tide that never recedes. Dark energy makes up nearly 70% of the universe, yet we do not know what it is. It may be a constant woven into the fabric of space, or a dynamic field evolving across time. Its effect, however, is unmistakable. The cosmos is not only growing, it is accelerating toward a fate very different from the one we once imagined. Project this expansion far enough forward, and a bleak picture emerges. In trillions upon trillions of years, stars will exhaust their fuel. New ones will form ever more rarely until the galaxies grow dim and silent. Black holes will swallow what remains, only to evaporate themselves over inconceivably long spans, releasing their energy into the void. Even the protons in atomic nuclei may not endure forever. Some theories suggest they too will decay, leaving behind a thin mist of radiation in a universe grown cold and dark. This is the heat death, the ultimate fate predicted by our current understanding, not a fiery end, but an eternal dusk, where time still flows, but nothing of consequence can ever happen again. Yet even this picture may not be final. The cosmos has surprised us before, and our grasp of its laws may be provisional, like maps of old cartographers that sketched coastlines vaguely and filled uncharted spaces with "here be dragons." The future may hold dragons of its own, phenomena beyond our comprehension today. One possibility is vacuum decay, a quantum instability lurking in the fabric of reality itself. If the universe is balanced precariously in a false vacuum, a temporary state of energy, it could someday collapse into a lower, truer state. A bubble of this new reality might appear anywhere, expanding at nearly the speed of light, rewriting the laws of physics as it passes. To any observer within, it would be instantaneous, the old universe erased, replaced by a new one with different particles, forces, perhaps different possibilities of existence altogether. Another possibility is cyclic cosmology, where the end is not an end but a reset. Some theories propose that the universe undergoes endless cycles of expansion and contraction, a cosmic heartbeat stretching across eternity. Each heat death might be followed by a new Big Bang, each universe a phoenix rising from the ashes of its predecessor. The cosmos we inhabit would then be just one chapter in an infinite series, each page written in fire and erased in silence, only to be written again. Still other visions imagine universes budding from universes, each black hole a seed for a new cosmos beyond its singularity, each creation branching like a tree in a forest of realities. If such possibilities are true, then our universe may be neither the first nor the last, neither singular nor alone. Instead, it may be part of an endless flowering of realities, each exploring a different configuration of laws and constants, each a laboratory of possibility, each perhaps nurturing its own observers who ask the same questions we do. The humbling truth is that we do not know. Our understanding, though vast compared to that of our ancestors, is likely primitive compared to what future minds will see. Just as medieval scholars once debated the structure of the heavens without knowing of galaxies, we may be debating dark matter and dark energy without yet glimpsing the deeper reality from which they arise. Perhaps one day, the great mysteries of the cosmos will be explained not as isolated curiosities, but as natural consequences of principles we have not yet discovered. What remains certain is that mystery is not a failure of knowledge, but its engine. The unknown draws us forward, urging us to build better instruments, deeper theories, broader imaginations. Dark matter, dark energy, the fate of time itself. These are not walls at the edge of understanding, but doors. Behind them may lie revelations as transformative as the discovery of galaxies, as shocking as the realization that the universe has a beginning, as humbling as the awareness of our smallness in the grand scheme. As we contemplate the darkness that composes most of reality, as we imagine endings that may themselves be beginnings, we are reminded that knowledge is never final, that truth is always provisional, that the cosmos is larger than our comprehension but not beyond our curiosity. The ultimate mystery remains not only out there in the void, but within us, the minds daring to ask, daring to wonder, daring to look into the darkness and see not only fear, but possibility. You are here, sitting in your quiet room, perhaps wrapped in a blanket of your earth, and now you return, carrying a vision of unimaginable scale. You are not merely a person on a planet. You are a being perched within a chain of cosmic addresses, each one broader, star of the Milky Way, itself just one galaxy among trillions. The Milky Way drifts within the local group, which clings to the outskirts of the Virgo cluster, which itself is a filament in the immense tapestry of Laniakea, a supercluster sprawling 500 million light-years wide. Even this, you have learned, may be only a pinprick of light in a universe whose true scale is larger by factors we can scarcely grasp, possibly infinite. This nesting of addresses creates a paradox that cannot be ignored. On one hand, you might feel impossibly small, smaller than a grain of dust drifting across an endless desert. Measured against the observable universe, your life is an instant too brief to register, your body a collection of atoms too fragile to endure. Yet on the other hand, something equally true and far more profound comes into focus. Despite all the darkness and distance, despite the abyss of time and space, the universe has produced you. You are a fragment of stardust rearranged into consciousness. You are the cosmos looking back on itself, trying to understand its own story. What could be more significant than that? Consciousness may be fleeting, but it transforms insignificance into meaning. For the hydrogen in your blood to think about galaxies, for the calcium in your bones to ponder the shape of space-time, for the iron in your cells, born in the death throes of stars, to ask questions about the fate of the cosmos, is nothing short of miraculous. Perhaps the most extraordinary fact of all is not the existence of galaxies or black holes or cosmic webs, but the fact that matter can awaken. Through you, the universe knows it exists. This realization brings us back to the present moment. The story of cosmic discovery is not finished. It is only beginning. Humanity stands on a narrow ledge of history, alive in a golden age where the veil of the heavens is being pulled back by new tools and sharper minds. The James Webb Space Telescope has already reached deeper than any human eyes before, peering across billions of years to see galaxies being born. Future observatories will trace even fainter light, capturing whispers from the earliest epochs, perhaps even glimpsing the fingerprints of life elsewhere. Every new image sent back to Earth is not only data, It is a time capsule, a message from a universe still unfolding. To live now is to be among the first creatures to truly sense the immensity of the cosmos. Imagine how extraordinary that is. For most of history, humanity believed the world was small, bounded by horizon and sky. Now, within a single lifetime, we've leapt from small world myths to cosmic truths so vast that they seem to stretch imagination itself to its breaking point. Future generations will continue this work, but we are the threshold keepers, the first to see the universe as it truly is. Tonight, when you step outside and look up at the stars, remember that you are not looking at a simple dome of light. Each star is a beacon from the past, its photons traveling across gulfs of time to find you. The light of Vega began its journey 25 years ago, before some of you were born. The light of Betelgeuse began 6 centuries ago, when the world below was lit by fire and guided by the rhythms of seasons. The faint light of the Andromeda galaxy began its journey when human ancestors still shaped stone tools, long before civilization rose. To look up is to read a chronicle written across billions of years, to see not the present but the ancient record of the universe unfolding. Perhaps that is the most humbling and the most comforting truth at once. You are small, yes, but you are woven into a story vast beyond measure. You are fleeting, but you are made of matter that has persisted for nearly 14 billion years. You are fragile, but you are also capable of thought, wonder, and connection, the very things that lift existence beyond survival into meaning. The journey continues, and you are part of it. Your atoms will not last forever in their present form, but they will rejoin the cycles of matter and energy that make new stars, new worlds, perhaps new beings who will ask their own questions about the universe. In that sense, you are not only a witness to the story, you are a participant in it. The cosmos does not stand apart from you, it moves through you just as you move through it. So here, at the close of this journey, pause for a moment. Feel the quiet of your own space, the steadiness of your own breath, the warmth of the blanket around you. These ordinary sensations are not separate from the vastness you've traveled. They are part of it. The same laws that shape galaxies shape you. The same particles that dance in nebulae compose your heart. The same energy that drives the expansion of space fuels your thoughts. To be alive is to be threaded through with infinity. In a universe this magnificent and mysterious, the fact that atoms can arrange themselves into conscious beings capable of contemplating cosmic immensity isn't just remarkable, it is the most extraordinary story ever told. You are part of that story, inseparable from it, forever written into its fabric. So close your eyes, fellow traveler, rest easy beneath the stars. The universe is vast beyond measure, and somehow, impossibly, you are part of its grandest adventure.